Thanks. So it is kind of a fun meta experience. As I just told some people at the front here, but like my dad lives 2 blocks away from here. And I will say it's been a really meta experience to wake up in your dad's house. Like, it was kind of like I was back in when I was 16. But now like there's a PyData in Eindhoven, and it's like in Veldhoven. I can bike to it. It's been fun. What I kind of want to talk about is how to prevent miles of scrolling and how to reduce the spaghetti code from the copy pasta. Because I've been teaching Python for a while. I've been doing this data stuff for a bit. But I've always seen people sort of like treat these notebooks as if they're junk food. And I figured I call it Untitled12.ipynb, but let's be honest, most companies, they reach like 42 or some arbitrarily large number. Like we've seen this Untitled 12 phenomenon happen. And the thing is, there's actually kind of a way of sort of approaching code that will sort of make those problems go away. Because I think a lot of people might have a way of working that can definitely be improved, and I just want to show you like a really quick hack to sort of solve most problems. After that, I just want to briefly point out the generality of it. It's not just pandas and notebooks that we can fix with this attitude. There's actually a whole bunch of things. And then I kind of want to maybe touch upon how to learn how to get there. But the first thing is like workflow really matters. And I remember when sort of this whole data science thing started, like in 2012 or something, I remember having to go to companies to explain why we don't like to use Excel for our analyses. Usually we like to use other tools. And there's a couple of reasons for it. So one of the main reasons of not using Excel, one of the reasons why I think it sucks, is we want to separate the data from the analysis. One of the really, really painful bits of doing analysis with Excel is that it's really hard to figure out if that cell is like calculated or if it's actually raw data. You don't necessarily have that in an overview. And that's sort of a source for errors. Another thing that I didn't much like about Excel is it was kind of hard to automate the analysis. So you have to you get a new data set in, and again, you kind of have to do the manual tweaking, and it doesn't really feel like you're a proper IT person when you sort of do everything by hand all the time. The other thing I didn't really like about it is that the analysis wasn't really reproducible. If someone had an Excel file, mainly because the data analysis weren't sort of separated, but it's really hard to reproduce some Excel analysis that someone else made. It's really hard to add proper documentation to it. And this is kind of the last one is kind of more like a personal concern, but I think we should not pay a third party obscene amounts of money for something as basic as arithmetic. I really think the budget is better spent if you allocate it towards education of staff or like an office party or whatever innovation. I really think that in 2019 we should not pay a third party to do this. And I also think that Excel is still sort of around. I think too many analyses are still done with Excel. And I actually think it's kind of frightening. An insurance company depends on the floating point arithmetic of an Excel spreadsheet to make sure that our pension plans are being calculated correctly. And frankly, I think that's kind of frightening. A lot of this, thankfully, is changing now that we have tools like Pandas and Jupyter. So that's good. But if I'm being very honest, if I look at how most people use a notebook and how they use Pandas, have we actually solved all of those 4 points? Is every notebook really separating the data from the analysis? And is it super automatable? And is our analysis reproducible? I mean, I guess we've solved part 4, but I think for a lot of analyses, we probably haven't really consciously touched upon the first 3 things. So what I figured might be fun is I'll just show you how I think most people start with a notebook and how they do an analysis. So I'll just do some live coding here. And hopefully, after 5 minutes of live coding, we'll have seen many things that have gone wrong, probably because I don't have the right attitude of approaching a notebook. And so people say don't do live coding during a talk, and I'm just going to totally ignore that advice. So here is a Jupyter Lab instance, and there's a notebook called Untitled12. I've imported NumPy, I've imported Pandas, and I've imported Matplotlib, and I have this data set that I'll be playing with. Just want to show you a really cool feature that you have nowadays, actually. So what you can do, you can click this plus symbol in a new version of Jupyter Lab, and besides the terminal, which is great to have in there, there's a new feature called a contextual helper. And the contextual helper is badass. What you can do is you can just have contextual help here. And if your cursor is, let's just run this. Oops. And the idea being that, this has to run. Okay, load. If your cursor is over a function from any sort of package that has a doc string, what the contextual helper will do is it will just sort of show you the documentation on whatever thing your cursor is over. So no need to do the question mark in front of the function name anymore. As long as you have the contextual helper there, that's your helper right there. And I would love to use it like in this case, but I kind of want to zoom in, so I'm going to close it up. But probably one of the first things that people don't really do much is just appreciate all the features that Jupyter has. Maybe taking a step back and just appreciating some of these extra things that you can use is also a thing that's going to help you a bit. And especially the contextual helper. This thing is like badass. It totally changed the way I work. But anyway. Analysis, that's what I want to talk about. So this is one of my favorite data sets. It's from World of Warcraft. You might have heard of this video game. The idea is that you have a character ID. This character was a level 1 orc rogue. It's like a super serious analysis. This level 1 orc rogue was apparently in Orgrimmar, which I think is the capital of Orc country. And this person was around at a certain timestamp. And we can see if the person was or was not part of a guild. And a guild is basically a bunch of people that slay dragons together, but you're in the guild or you're not. And one thing that I thought was interesting about this data set is the way it works is every time that you're logged in, there's sort of this heartbeat in the system. So every 10 minutes, if you're still playing the game, there's going to be another row of data. So that means that I can see how long a person is playing the video game. And I can therefore calculate how long it takes to get to level 60. Right? So I can sort of calculate how much human time has been wasted on this video game, so to say. So that feels like a fun analysis. So in order to sort of play with that, one thing I probably want to do is I want to sort of group by the character. And then what I kind of want to do is I want to sort of, well, I don't want to assign this, but I want to aggregate this. And one thing that I probably want to calculate is just the number of rows. And I don't know, if I'll just take the level column and I can just say I want the np.size function to work on that. Doesn't work. Level doesn't exist. Why is that? Let's look at df. I think level does exist. But the way pandas works is you can have a space in your column name. But no worry. What I'll just do is I'll just fix that. So I'll just do c.replace. I'll replace the space with, I don't know, nothing. And then for C in df.columns, I'll just do something like this. Oh, okay, this is super clear to everyone. Great. So what I'll now do is I'll put brackets around this. And I have the number of rows, which is kind of cool. What I'll do next is I'll just calculate the min level. So that's the level, and I'll calculate the np.min of that. And what I'll do next is I'll calculate the maximum level. So that's level and then np.max, so that's also kind of good. And I think what I probably also want to have is I want to have if you're part of a guild. I need to sort of summarize that in some way. And I kind of glanced over it, but as you can see in this data set, you can have like a -1 in your guild, which basically indicates you're not in a guild. Okay, so let's touch on that. So I'll just do your guild is, I don't know, like your guild thing, and then I'll do np.max. And then I have a bunch of statistics here for the characters and the whatnot. So what I'll just do, this is a nice little intermediate result, so I'll just call this df2, and then I'll move on. I think we can see where this is going, right? Because I probably need some other data set as well. Because what I kind of want to do now, maybe, is that I sort of think to myself, like, you know what I kind of need? If I want to do research on what the effect of the guild is, what I probably need to have is I probably also want to have, you know, how many people are in the guild. I think if you're in a small guild as opposed to like a big guild, then probably that might have an effect on how you're leveling, right? So I don't just want to have df2, I want to have df3 as well. And in that case, what I just got to do is I got to group by the guild, and then I just do this one aggregation, and I'll do something like, I don't know, a number of characters is equal to, I'm counting, yeah, so I think what I got to do here is just do character, and then number of unique, I think, as a string should do this. And it's waiting a bit, but all right. Yeah, and so most people are not in the guild, but a bunch of people are. And then what I got to do is I got to sort of, I kind of want to join this data set back up to that data set. So probably what I got to do is like df3.resetIndex. And then what I got to do is I got to call df2.merge. Right, so what I have now is I sort of know the guild number and I know how many people are in that guild, and this is sort of now combined. And I get to increase this guy with another number, which is great. And at this point, what you can sort of do is you can sort of say, you know what I'll do is I'll just make a sort of a plot out of this. So one thing that I can sort of do maybe is, I think matplotlib is on, so I can do like a plot, and I can say scatter, and I can say df4, and then I can do something like, you know what I want to do is I want to check the number of rows, and I kind of want to check what the max level is then, I suppose. That might be something that's interesting to see, right? So the more someone has been playing, the higher their max level is. All right? And I guess that's kind of cool, but I'm actually a little bit more interested in sort of the level increase, I think, right? That might be better. So what I can do is I can do df4, and I can do something like max level, and then minus df4 min level. All right, something like that. And what I can do now is I can sort of, you know, even though this operation is actually supposed to go maybe in between here, but that's not how the world works because I'm thinking out loud and then typing. So I'm going to keep this line here, but now I can sort of say, hey, here there's a level increase. Good, nice. Now, so timeout here. Bunch of stuff that will go wrong. Suppose that I show this to someone. I mean, for starters, probably the person who has access to this notebook doesn't have a folder called users Vincent downloads, right? So that already is kind of an issue. And what's more is if I now were to share this with people, I'm creating the variable name under the chart that needs it. And that's not even talking about all this df4 nonsense. But the thing is, I'm kind of looking at all of your faces. I think a lot of people recognize that this is sort of a flow that everyone is using while making a notebook. And I get it, right? So if you're doing this, like you're sort of in the zone, and hey, I kind of understand this data set now, so I'm on fire, so I want to keep on doing the coding and stuff. But then, and I get that feeling that you want to sort of really dig deep and like dive into the rabbit hole. But maybe that's a dangerous thing to do. Probably if I'm going to do like a primary analysis and then I have found a conclusion that might be interesting, then I kind of want to be sure that that conclusion is at least correct. And I kind of want to make a system that's very easy to iterate on that I can actually share with my colleagues. So this way of coding, it's not going to work because you're going to end up having to rewrite this. And that's not effective. And you know, I'm sure that we kind of agree, if I continue on this path, I will end up with a notebook where I can scroll for miles and miles as well, right? Which is also kind of a painful thing. So what I'm going to do now instead is kind of come up with a better notebook. And I'm just going to start by saying, how about I just call this notebook what it is, whoa churn analysis or something, right? Just give the notebook a name. And I guess what I'll just go ahead and do is I'll just, you know, take that code, and I'll take this code, and sort of use this as a starting point, and now sort of think about stuff that I could be doing. Okay, so the data set's loaded. And I mean, one thing that I could, for example, do, like typically when you start out with a data set like this, I mean, if I think about all the steps that are happening here, technically, this changing the columns thing, that sounds like I'm cleaning the data, right? And if I think about most analyses, there's probably usually, kind of like always, this sort of phase where you're cleaning your data set up. So how about I just give that a name, right? So I'll just make a function called clean data set. And some data frame will go in there. And then in this case, I'll just return that data frame. I mean, that can be fine. And then, you know, one thing that I could then do is I could then also think of, hey, what are some other things that I typically want to do? Well, there's probably a phase called remove outliers. Right? There's also probably a phase that you're going to do. And I can kind of imagine that the way that I remove outliers, there might be parameters for that. And the function kind of allows for that. That's kind of nice. But then at least all the logic on how to remove outliers is kind of contained. Because if I look at this, the problem here is not so much that this code doesn't work, but it's that I don't have an overview that here I am aggregating and here I'm adding features, so to say. It might be nicer if I have a function that says add features, and that way when I look back at it, I know, anywhere where there's features being added, it should happen in that function. That makes it a lot easier to debug. The only downside is, if we're not kind of there yet, but like one thing that might happen is that you do something like remove outliers, clean data set, and then you put your data frame in there like this. And this is kind of hard to read, right? So the downside of this is you kind of have to read from the inside all the way back out to the outside. Luckily, Pandas was looking at how the R language deals with this, and it kind of made this cool trick. So what you can do these days is you can just say dataframe.pipe, and then give that to this function. And in this case, I'm going to give it to the clean dataset function first, and then to the remove outliers. And the idea is that you take the data frame, it will then be given to the clean dataset function, and it will then be given to the remove outliers function. And there's a couple of things that I really like about this. For starters, I don't have to think about the logic of my analysis whatsoever, but I can already write this down. And this already gives me kind of a framework of mind, it gives me a bit of calm, and this is sort of a great starting point for me to sort of fill in the blanks. And also, as you can probably imagine, if I'm increasing and increasing my analysis, as long as I can sort of figure out, do I need to have a new step here, or does this action I want to do, can I put that in another step? That, to my mind, makes it much easier not only to do the analysis, not only to iterate on the analysis, but it also makes it a lot easier to maintain. There is a trap, though, and it's a Python thing, but I just kind of want to show you. But I hope we kind of like this idea. It gives us more of an overview. Like, that feeling is good. That's very important. But let's suppose now I implement this clean dataset function, right? So what I can do is I can say dataF.columns equals, and then I can do c.replace for c in dataF, something like this, right? And then what I could do, just to clarify, I can check if the columns that come out of this, I mean, there's no space in there anymore. So that's a good thing. The awkward thing, though, is that the same thing holds for the original data frame. And that actually is a problem. And we kind of saw that happen here as well. The issue kind of is that if you're changing a data frame as a step somewhere, like you're actively changing a property on top of a data frame, then everywhere that property is changed. So this action, it would be kind of nicer if the clean data set just takes this data frame and it goes in there, and then the data frame that comes out is updated without there being any side effects. And in this particular case, a thing that I don't like, and in general it's a cause of errors, is this one function has side effects, which is no bueno. One really easy way to fix that is to just make a function called start pipeline. And the only thing that this function will do is it will return a copy of the data frame. And if I do this, I mean, I will have to restart this, of course. Yep. And now if I do this, you see that we didn't change the column names of the original data frame, but we did change everything in here. And I can kind of hear the troll in the audience sort of go, but Vincent, that's super inefficient. Like, you know, that's, screw it. I think at some point you can stare yourself blind at this concept of efficiency, but what I hope to show you here is screw efficiency, this is more effective. I really think it's okay to like waste like 10 seconds of compute power maybe, if that means that in the long run I don't have to spend hours maintaining it. So as you're writing this code, maybe also the attitude here should not be, hey, I'm focused on performance. Maybe what I'm trying to do here is I'm just trying to explain the recipe. What I'm doing here is I'm making a cookbook. This is the recipe for the analysis that I kind of want to do. And when I'm cooking a chicken, well, I don't cook chickens because I'm vegetarian, but if I'm cooking a chicken, I tend to care more about flavor than the speed at which the dish can go out to my family, right? I think that's a better attitude to have. But there's a bonus with this as well. So I hope that we sort of experience this sort of calm of mind kind of thing, but there's actually a sweet little bonus that we can do too. So one thing we could do is, because all of these things here are functions, there's actually an extra trick that we are able to do. So I will make a badly spelled function here appear called log. And I think, have we heard of decorators before? Right, so yes, some of you have. So the idea with a decorator is it is a function that accepts a function and returns a function. It's really functional. Here's how it works. What you can do is you can say, hey, I have this wrapper that's sort of on the inside, and let's just have a function. Well, we're going to declare a function in here that will accept a data frame as its first argument, and then it gets arguments and keyword arguments. And let's just do something like import datetime as dt, because I'm going to do something with timing how long this takes. And one thing that I could do is I could do something like, okay, we have a tick moment, that is the dt datetime.now, and then we have a talk moment, which is the dt.datetime.now. And what I can do is I can say, hey, there's a result, which is essentially this one function that goes in, and I'm giving it the data, the arguments, and the keyword arguments. And I will return the result now. But before I do that, I will actually print an f string saying, I can sort of say f dunder name. This is the name of the function, took. And I can do something like talk minus tick. And then every time I have a function that accepts a data frame and outputs a data frame, then I sort of have a nice little decorator here that might be able to do some logging. So what I can do is I can do wrapper, return wrapper here. And kind of the cool thing now is I can say, hey, let's add this decorator to all of these functions, right? And let's now also do this, and let's call this clean df, so what comes out of here. And if we didn't make a coding error, a kind of a nice thing that we get for free here is that if we have a function here that's kind of like nice and general, then we kind of get logging for free. I don't know about you, but I like stuff that's free. Because now I get to think, hey, what's important for me to log here? And in particular, one thing that I can imagine for this particular use case, I'll be removing outliers, right? So one thing that's probably important for this particular analysis is that I keep track not just of the shape of the data frame, but also of the number of characters that are still in here. So I don't just care about the rows. If at some point I have an analysis and I only have like 100 characters left, then I know that my analytical power has sort of decreased. So one thing that I could go ahead and do is I can sort of do something with this result, and I can do something like shape equals, and I can do like the result.shape. Right, let's add that. So there's a shape there as well. But one thing I can kind of do is I can sort of say, okay, took equals, right? But I should probably also be able to say, what's the nicest way of doing this? I guess I could do result.group by car ag, and then I can do something like ncar equals, I don't know, car np.size. And I think if I get the shape of this gap, this is like the n characters, sort of. I think that's a tuple, but I don't know. Something like that? Right, okay, so then I should do nchar of 0, but I hope you catch the drift. I'm able to add logging features that are important to my analysis. But here's the epic thing. Now suppose, as luck might have it, that this analysis is something that will actually go to production. Notice that we've just fixed logging. And also, just an extra bonus. Suppose now at some point that these functions are well written and well defined. What I could even do, this is an amazing feature of Python, you can make a file. You can call it common.py. You can put that stuff in here, and then you can import it. And that's important. And the reason for that is that means that we can now use the notebook as a scratch pad, but the moment that the function is sort of mature enough, that we can remove it from the notebook such that the notebook then becomes the summary. It becomes a user interface. It becomes a place where we can sort of very quickly make nice little charts instead of it having to be like the repo of all of our sort of analytical steps. And of course, a next step would be to sort of not just have this in the common.py, but to put this into a package, right? That would be a nice little next step. You can automate that with a cookie cutter. I've open sourced mine. But then also a very, very awesome thing is, this is a function. You can unit test that. So not only do we sort of have this nice little way of sort of separating the macro part of our analysis with the micro part of our analysis, but we have a very nice way of unit testing this so I sleep better at night. And I don't know about you, but I like having pager duty off on a Sunday. But also I'm just happier because I think it's going to be a whole lot easier for me to sort of change the analysis if I'm able to sort of make quick changes on this level. Because a very convenient thing is what I could do is I could say something like, hey, I have a minimum number of rows that I have per character. And as long as this keyword argument that I have here also exists here, you know, then you can fiddle around on a high level and keep the details on a low level, and therefore separate into two different levels of abstraction, which is the whole goal of programming. I'll take questions after. Fine. Okay, what's the question?
For sure you're going to get to Python start pipeline at some point, so why not like the start pipeline and decorate too?
You would add, you could, I guess, but then you're copying a lot, right? And you're copying on every single function out there. There's another reason to have start pipeline in here. Notice that, suppose that this clean data set removed a couple of columns. By having start pipeline in here, I have this one log line that tells me how big was the data frame before we got started. I think that, for me, that's the main reason of having a start pipeline. The copying thing is nice. It's a cool security mechanism. But I like having that one log line, because if I didn't have that start pipeline function, the second line of the logs will not show me the original size. So it's a cool idea, but I kind of prefer this. So I can imagine, and this is something I've learned while teaching, understanding a decorator and understanding a lot of these steps, it kind of takes a bit of maturity as far as being a Python developer goes. I do genuinely think that if you're just getting started and you're reading the pandas documentation, you're not going to hit this great habit, probably because a decorator is a relatively advanced thing you can do in Python. It's not just common scripting. So it might be nice if just, there's some easy tools here that might help you with this. So there's this package I've made together with a bunch of lovely people. It's called Scikit-lego. It's a really cool, we have stickers somewhere. But one thing we've added, and this is sort of the idea, like I've noticed that for pandas and for scikit-learn, it's not so much that the pipeline isn't there, but it's more that sometimes you need like a little Lego brick that you can just click in there for your particular type of analysis. So if you're interested, we actually not only have the log step as a feature, but we also have a tutorial on how to get it to work with the Python logging framework. So what you can actually do with this log step that we have here is you can actually sort of say, hey, not only do I want to log this step, but also I want to set the logging level for this function to be different than the logging level for this function, such that in production I'm logging other stuff than stuff that I have in my notebook. So if I look at where we then are, I mean, I think if you write the, if you do the piping thing, you will actually just sort of for free are a lot closer to solving the first three problems. Literally, you've also solved the fourth one because it's for free. But the thing is, like I've sort of noticed that if you're doing data science and stuff, don't worry too much about the algorithm. Don't worry too much about the deep learning stuff. Like Google has obscene amounts of compute that you don't have, so what they are doing might not work for you. It's a different signal I just lost as well. But yeah, I've made that point. Okay, whatever. But what I hope, though, is that what I've just shown you is that if you're interested in reading more about this, everything I've just talked about, I got that from a blog from one of the pandas core devs. It's not something I came up with. But I kind of want to hope that this feeling of just clicking stuff together, just note the beauty and the generality of this. I mean, you can teach this approach to a team, and then everyone can still write their own functions their own way, but at least there is this shared principle approach to code that everyone can adhere to. And just that is going to make it a whole lot easier for you to communicate what you're doing to your colleagues. If we all just promise that we have a clean data set phase and a remove outlier phase, and that everything else is sort of very particular to the analysis that we're doing, the only thing you got to do is come up with a good function name that describes what you're doing. And you can actually actively focus on that. And I've had code reviews where we spent 10 minutes coming up with the best name for a function, and I think there's value in that. So pipelines need Lego bricks, and I've been fortunate enough to sort of have this experiment become a bit successful. We have about 2,000 downloads a month now. We are even, it's weird, if I push to PyPI, I immediately notice the CDN providers picking it up. So after I've made a new version, within 5 minutes, I have 300 downloads from all the CDNs. So it's like a huge compliment. There's a couple of Dutch companies helping us out with this, and a guy from Brazil. If you're interested in this, find us on GitHub. We have lots of fairness algorithms as well, if you're interested in that. But we kind of see this as a very cool experiment to just come up with, hey, what are some good industry practices that don't necessarily fit well in scikit-learn or in pandas, but is stuff that I would maintain it because it's stuff I want to use every day. And I'm not the only one doing it. Matthijs is around there. So we are the two main maintainers, but there's a bunch of other people. Come and enjoy the fun. Also, just to emphasize, this is why Scikit-learn is amazing, right? Scikit-learn gives you this pipeline, which sort of automates a whole lot of cognitive load away from you. And the pipeline is a bit different, because this pipeline actually requires state. So that means that the Lego bricks in this particular case are not functions, they're objects. But the whole point is that you have a pipeline, and that's the thing that's making sure everything runs fine. For me personally, this is why Spacey is such a badass project. NLP algorithms are great, but only when they click together. And for me at least, the problem that Spacey has solved is just making sure we have a convenient API or a convenient pipeline abstraction to do NLP stuff. Which means that you can bring your own Lego bricks, which is the beauty of it. Also, it has an amazing community. Like, join it. Spacey is amazing. But I hope that I've kind of demonstrated something general to all this too, because there's a great cooking analogy. How I think most people cook is they take the chicken, they season it with spices, then they season it with gravy, and then they put it in the oven at a certain degrees of Celsius, and then they serve it on a plate. What they don't do is serve the thing that you put in the oven, which is the thing that you seasoned, which is the thing that... Code is language. There's no human being who would consider talking like this. And there's also no human being who would consider talking like this, right? But if we are to maintain something, then I prefer to have something that you can just read from left to right, top to bottom. And a pipeline is a really nice way to make sure you always stick to that. A pipeline is literally this, then that, then that, then that. So consider that code is more like a user interface for thoughts. And it's really important to get it right. Because I think if you invite clarity and interoperability, you're going to get a much better sort of experience in your career. It also is what I think makes R a really nice language. So just some advice, I guess. I mean, maybe really don't worry about learning the latest deep learning technique. Instead, invest more about having stable code. It's typically more of a productive concern to worry about, hey, how can I communicate clearly with my colleagues, than how can I use this super complicated model. I've never seen that idea work. I'd love to hear someone say, oh, I tried something super complex once and the team immediately got it to work and it was great, green fields and rainbows. It's just that what I have heard, though, is hear stories of, hey, we actually took 2 months to sort of really talk about how should we communicate with each other, and now we live in a more calm environment. Clarity will typically cause many improvements in the long run, and the calm that will follow is likely going to have a greater impact on innovation compared to yet another library that can flow a bunch of tensors. Typically, Pandas is a tool that you will use daily, so it feels really weird to me that people don't make sure they 100% master it. If it's something you use daily, then it's something that you really want to sort of get to the bottom of. And I do think probably more time is spent in Pandas than in Scikit-learn, if I'm honest. And it's a bit meta, but and your experience might certainly be different, but I have found it to be extremely effective to have this calm. Because if you have this sort of calm, hey, nothing is on fire kind of vibe going, then that means that you can pause and kind of reflect on how everything's going. And without this pause, you cannot really find a thing that you can improve. It doesn't give you an opportunity to rephrase what's happening. So don't go down the rabbit hole of Untitled 12. It's like haste makes waste. And it's kind of meta, but if I really just think about it, I like to make drawings when I think about stuff, but I really think that you have to reflect in the calm moment that you are in, and then you're able to make a good investment in your habits, and the joy will just accumulate. It's something that will sort of get better over time. But the problem is that most people think, oh, I should focus on the habit. I think you should start to focus on the reflection. Just take a moment every week, look at everything you've done, and wonder, is there something that we might be able to do better? And with that, I mean, stuff that I've been doing lately, I kind of noticed that I have lots of these itches to scratch, but then nowadays I just don't wait for someone else to build it, I just fix it myself. So I've noticed for teaching, I've always had this weird use case that I just want to draw a data set and then just use it. So there's this, thing I made. It's called drawdata.xyz, and what you're able to do is you can just draw a bunch of points, and you can click a button that says copy CSV, copy JSON, download CSV, and there's a reset button. It's a free tool. Go ahead and use it, but scratch your own itch. But before you scratch your own itch, reflect if this is something that you want, and typically it's a lot easier to solve the right problem if you understand the problem very well. The future is awesome. I think the only thing we got to do is just build it. Almost exactly. Kind of bummed out by that, but oh well. Thanks for listening.